We are live.
Okay, hi everyone. So, welcome again. Today we are having our fifth module of the fellowship program, and today the module is covering IoT, connected systems, and green AI. So, the module will explore how connected digital system can drive sustainability outcomes from IoT sensors, network optimizing energy grids, and water infrastructure to green AI principles. So, as usual, this module, as part of the fellowship program, is being organized jointly by the Global Ambassadors of Sustainability, the Global Green Chamber of Commerce, and the Green University Network at the Kingdom of Saudi Arabia. So now I'm inviting Ms. Michelle Thatcher, the CEO of the Global Green Chamber of Commerce, for an opening remarks. So the floor is yours, Michelle.
Thank you so much, Dr. Wissam. And again, welcome everyone. We're so happy to have you with us. So as Dr. Wissam has shared, today we're focusing on the IoT and those connected systems. And just in case that term doesn't, ring a bell for you, it probably does, but the IoT is the Internet of Things. So if that's new to anyone, it simply means that those physical devices, things like those sensors, meters, equipment, vehicles, and building systems that are connected and are able to collect and share data. So that connection does allow us to understand what's happening in real time, and increasingly, hopefully we can respond much faster with that. And so we have a terrific group of speakers. As you can see today, looking at different angles, we are looking at AI and governance, cybersecurity, green AI, connected systems, and digital twins for energy. And we'll just jump right in here this is super exciting where we are today because it marks an important shift in this particular fellowship. We've completed our first 4 weeks, the tech to market bridge, and we now move into our digital to community bridge. So this is where technology starts connecting much more directly to those systems as people rely on every day. So from energy and water to buildings, transportation, and communities. So hopefully you've finished the first phase. And if you haven't, go back and you can watch any of them, get your certificate. And once we finish the fellowship, if you've finished 10 out of the 12, you can receive your fellowship. So hopefully we encourage everybody to jump in there and get started if you haven't already. And today at its core, it's really about how we move from simply collecting the information to using it. So because connected systems can help us identify whether it be a water leak, maybe there's an imbalance of energy demand, we might want to improve industrial efficiency, or perhaps we just we're adjusting for the building of unnecessary waste of energy or water, et cetera. So the opportunity isn't just more about the data, it's about making sure that we have better decisions and we can create much faster action than we have in the past. So just key takeaways as you listen today. So keep in mind 4 ideas, whether it be connected systems, can move us from monitoring problems and responding to them. We see AI and digital twins can help us become much more predictive. We look at efficiency it also has a way to come with resilience. And technology only creates real impact when security, governance, ethics, and measurable outcomes are built into the system. And we always want to look at the actions. It doesn't, we can learn all day long, but if we don't start taking action. So here are some key actions, are pretty simple. Start with the sustainability problem and not the technology. Know what you're trying to improve and make sure that you then measure it. build the technology, security, and governance together. Remember that, and then measure what is actually changed. That could be energy saved, resources protected, resilience improved, or hopefully environmental impact reduced. And before we continue, we'd like to take our moment of silence together. Today, there are people around the world, as we know, facing conflict, whether it might be displacement, uncertainty, and we have, unfortunately, a lot of loss. And many are simply hoping for safety and peace within that. So, wherever you're joining us from today, we just invite you to pause for a moment. Think of someone, a community, or even part of the world that could use a little more kindness, strength, peace, and love right now. Take one moment. And let's carry that intention to give that strength and peace and love to our speakers so they may guide us in our work. Thank you so very much. And with that, I'm happy to pass it over to Hajra, our International Sustainability Program Manager, for her friendly reminders and a few ways we'd especially love to hear from all of you today. Hajra?
Thank you so much, Michelle. Hi, everyone. Welcome again to another week of the module. We encourage your participation as always. Please share your thoughts, reactions, and insights as our presenters give their presentations. Please tell us where you're joining us from today. And when you're asking questions, make sure to also put the speaker's name at the beginning. So if we don't get time to ask your question during the Q&A, our speakers can go back and answer your questions on LinkedIn. We appreciate all of your uplifting, inclusive dialogue that we have, and we appreciate all of your reflections as well on this program on how we can improve it. We're really looking forward to hearing all of your insights and thoughts, and I'm going to pass it back over to Michelle.
Thank you so much, Hajra. And now I'm just very happy to pass it back to Dr. Wassam, whose leadership through the Global Ambassadors of Sustainability really continues to bring us all together, this such extraordinary global community. And we, as Global Green Chamber, are just genuinely honored to continue building this fellowship along the Global Ambassadors of Sustainability. So I'll pass it to you, Dr. Wassam.
Yeah, thank you so much, Michelle and Hajra. So now we start with our first guest speaker, Dr. Lina Patel. Dr. Lina, she is the founder, owner, and CEO of the Global Entrepreneurial System from India. So the floor is yours, Dr. Lina, and you have 15 minutes, please.
Yes, thank you so much. I sincerely convey from India the sincere gratitude and welcome for everyone, one and all present over here. I convey sincere gratitude and thanks to Global Ambassadors of Sustainability, Dr. Wassam, and Green Chambers community, Commerce of Chamber and community. I really privileged today to present my presentation on a very sensitive topic worldwide, which is IoT connected systems and green air. So, friends, the world is nowadays global, as we know that every single corner of the world is connected beautifully, yet somehow dangerously as well. So, my very first expression from my end today, with my POV, that our world is becoming no doubt increasingly connected, but important question is not simply here we need to ask that how connected are we. This is not a question, but it's more meaningful important question is how intelligently and sustainably are we using that connections. And because of that, the only technology is not in the picture, centralized idea of the picture, but yes, the more greener world and more resilient and more sustainable, fruitful outcomes, what we expect at the end of the day on the floor of humanity is more about the central idea. So welcome again. Let's get back with my slide one by one. Here we go with context of the connected systems. Yeah. So only one voice I would convey and appeal everyone to connect with that everything what happens around us in our surroundings we are able to sense it. And immediately, by the natural ingredients of the Almighty in each human, that we can easily connect. But after that, it's about a decision. I mean to say, we are here and there to decide how can we scroll these all the connections towards the optimization, and ultimately at the end of the any sort of inventions and the innovation as a green word. I mean to say, let's pick up this word towards green AI. So IoT creates Internet of Things. Basically, it's a live operational layer where we are not only collecting data from the assets, environments, and people, but actually through the interfacing and connected control and systems, we translate visibility into more smarter energy use, and we can say that very faster inventions we can go ahead with the same frameworks and all. Yes, indeed, we can turn out the measurable environmental performances based on that. So from my point of view, connected systems turn signals into an action, and that's very, very sensitive. That's to be optimized over here. Let's move to the green AI. Here I would quickly smartly cover that. What is green AI? Everybody is familiar and crazy about this word AI. Right now, the world is more artificial than human, if I'm sure. Okay. So from my POV, it's all about appealing all the intellectual human beings across the world that we are living in this dark era where AI must be transformed now into green AI. What is green AI? So, what we feel here is that after connecting all the signals from the surroundings, from the system, connected systems, and all that, we need to understand that through the connection of IoT, how can we first of all build green AI? It can be understood here with the three levels that AI is designed to, first of all, minimize environmental impact while maximizing computational efficiency, where we can say this is extremely important, right? Because artificial intelligence has enormous potential, right? But AI itself is looking for the better resource allocation, electricity usage, and data storage and infrastructure. So first is we need to understand that energy efficient algorithms must be activated and must be in such a way built that AI is still not sufficient for us, and we're looking for the green AI to build more greener solutions towards the frameworks. Sustainable data center practices, second layer we can achieve that data centers are occupying the maximum area of the lower land covers, and land covers are occupied with the population and residual blocks, right, worldwide. So we need to grow this practice as well, that how can we turn our data centers more sustainably established. Third is environmental monitoring and optimization. This is the wide, huge aspect where we just not only intend to optimize, but we just initially, monitor environmental issues, aspects. Based on that, we can think for the greener AI with the solution that, okay, fine, this goal is not simply more AI, but the goal is, better, smarter, and more energy efficient AI. So it's all about my green AI, and we can move now forward with the closed loop for IoT data feeds. I mean, after IoT creation, connected systems are there. Once upon a time, if we move towards green AI, still there is a lack in creating closed loop. For that integration, we require green AI models that forecast the demands, detect all the waste, and based on that continuously we tune the resource use. I mean, how can we destroy the wastage? Not only destroy the wastage, but we can exactly recycle it, right? So here the sensors capture occupancy with the weather. That will be the most prominent idea there. We can adjust energy consumption. We can understand in a one line that energy consumption is becoming more higher and higher, so we need to monitor globally. Then we can slowly predict about the actions turned into optimization. So that's all about the story where we can use this closed loop for sustainability to achieve in our performances, right? Being an engineer, it's still not sufficient for all of us that using AI, innovating and inventing, more and more smarter. But yes, we should never forget that with this word smarter, the one word must never be forgotten, that is greener. Okay. So this concept can be expanded beyond these buildings and beyond the infrastructures. It can be applied to the factories, we can say transportation systems, agriculture, resource systems with the cities levels and state levels and national levels and energy networks, where wherever we can think, we must think. So this is all about our green IoT on this earth planet. We are born as the human, obviously not as robots. So we need to understand the importance of the application always. So let's look some of the real applications from my point of view. Here you can see the precision agriculture where farmers are most benefited with the IoT sensors. Using greener AI, we can optimize the minimal use of energy consumption, and we can stop the energy wastage across the globe. But these are the challenging innovations where ahead when we highlight with the word green AI. Still, AI is no doubt in the central idea. So the second is smart grids. After that agriculture aspect point of view, we need to think about smart grids. Right now, we also looking for the green computing. There was an era that was started with the grid computing. Slowly, it was evaluated into cloud computing, and after that, cloud computing. Now we are in the era of green computing, right? So, if I'm sure that computing algorithms are more beneficial in the circular waste management systems. So here we can connect monitoring and intelligent analytics that can be helpful to all of us to independently improve the resource utilization across the globe, right? So for me, circular waste is a very we can say ignited path where we can achieve more greener AI to be on the floor. And last is fourth, my application to be discussed over here today in very intellectual panel session, that's about cleaner air. Indeed, we are here as a human. Again, I am repeating, we are not the robots, and we need the air, clean air. And because of that, we need to focus nowadays more and more about the green computing systems, where more, eco-friendly systems we are manufacturing from the factories and localized areas where green IoT and it's not limited with the theoretical concepts, but we should turn it and tune it into the practical modes on the floor. After that, let's move. Value is real, so is the friction. I mean to say the benefits are really significant for AI. However, as the responsible technological professionals, we must understand that these are very challenging to us. But yes, indeed, some of the benefits I would cover here: reduce carbon footprint, cost savings through efficiency, stronger data driven decisions. These are our benefits. Looking forward with the trade offs where we see that the value is real, really, really, and so is the friction. We need to understand challenges as well, upfront investment, because without investment we can't make the plan successful. Yes, indeed. Moreover, privacy, security, and trust, these are the most burning three aspects on the floor with the challenge to each and every nation and each and every green IoT to be built up in the future. And last is skills and interoperability, means we need more and more skilled staff, skilled youngsters, skilled population throughout the nations. We have to be one now, instead of setting the boundaries and showing the boundaries that we are the one world, we are the one planet, and that way we have to increase the skill level. We need to help each other in such a way that smart infrastructures require like sensors, connectivity, computation professionals. So that time the role of the manufacturer companies and the factories will be in the pioneer central idea. The second is privacy, security, trust, that is based and that is worldwide approachable from everybody. So the third challenge is directly proportional to everything. So our each and every challenge is integrated. Definitely we need to understand one point, that these challenges are definitely different, looking different, but at the same phase. If we can use the different cross platforms, and if we grow the more communicative professional world and network, definitely with the interdisciplinary knowledge and the skills, we can grow our goals and we can achieve the goals in a very true fruitful sense. So, therefore, for me, sustainability cannot be achieved by the technology itself alone. We need more and more people involved in utilization of the technology plus policy. Policy is a matter where the responsible governance looks forward and take the stand from the nationality and international level. So this is what we cover, and the last few minutes I'll cover. Let's think more intelligently, that the intelligence moves closer to the edge. I mean, we are in the era where, I mean it, that where we are heading. One major decision over here is edge computing, right? So from me, it's an appeal that lower latency and lower energy. Through the edge computing, we can predict the maintenance, no doubt, but based on the predictions and the measurements and the parameters, we can definitely grow more inclusive networks. And when we think about lower latency and lower energy, it's all about our you can say longer asset life, right? And slowly we can gradually grow the sustainability in the wider global circle, where the standards accelerate adoption. So we need the standardized process in that, that can extend not only the resource allocation, but it should raise the standards that can adapt easily the green IoT, green AI, and definitely greener with the smarter solutions. Okay, so this is what I need to cover. And finally, total 5 moves for the green impact professionals we can think upon. The first is choose different efficient devices and softwares. So here I just need to cover only one thing, that we need to design such a way that single principle, not only working on the technology, but afterthought it's working with the more and more skilled empowerment professionals. Second is build across the world. Let's build cross disciplinary teams, that is not stick on the one domain or like that. Okay, so it's a hybrid level of knowledge worthy collaborations. Sorry, pardon me. Then secure data, practice, and ethical AI. Nowadays, more and more people need to go with the ethical AI science towards the security data, and moving forward with the confidential private data practice on the floor. So we need to keep sorry, learning as the technology shifts, moves rapidly. At the night, the version of the technology becomes the highest ideal one in the next morning. So we need to keep updated ourselves with the technology shifts, as well as we need to advocate, lastly but not least, for sustainable digital infrastructures. I think every computer, every technological person should advocate. We are the ambassadors. Yes, indeed, because we influence the world towards the best usage of the green AI. Now, few more last things. If you have the question regarding this advocacy and all that, we can discuss. But closing expression, I would give that as I conclude over here. The first, I would like to leave with a simple thought, that the future is not about connecting everything, but the future is about connecting everything with the purpose. If I have the purpose with connection, right now I'm connecting with you guys globally, intellectual panel, that yes, I do have the purpose for introducing more and more sustainable ideas I can share, I can learn from you. So this is how it takes the shape over there, and IoT gives us a lot of ability to sense this. And it's not about only limited sense. After sensing, we need to communicate with each other. I communicate likewise, you communicate with me. We can share a lot of ignited ideas and the sustainable solutions to grow with the green IoT and green AI. So AI gives us the, we can say, the ability to understand and predict, and that's the power of humanity, where we can not only think about the green AI challenges, but we can definitely respect the resources. I mean, to say utilization of the resources each nation wise across the globe. So at the end, I would share happily that if we bring this, technologies together responsibly, we can definitely move to the predictive systems, from the west to the optimization, we can say, from technological progress to the sustainable progress. And lastly but not least, let's therefore build systems that are not only smarter but also sustainable, not only connected but also responsible, not only intelligent but also inclusive, and not only designed for today's needs but created for our future generations. Okay, so at the end of this, I would like to thank you, Dr. Wasim, and the team and Green Chambers. I really convey my sincere gratitude. You give me the opportunity to share what I feel regarding this IoT connected systems. How can we come forward towards the more green IoT, green AI solutions towards sustainability development goals to achieve on this planet? Once again, thank you so much. Happily noted. And any more questions? Thank you so much.
Thank you so much, Dr. Lina, for this interesting topic and sharings. And now we move to the second guest speaker, Mr. Anzar Hassan. And Mr. Anzar, he is leader of fractional data and AI governance from the US. So the floor is yours, Mr. Anzar, and you have 15 minutes, please.
Thank you, Dr. Bassam and Michelle and the whole team. And I will be cognizant about the 15 minutes time because I know the other speakers too. Although my presentation is very long, but I try to be very high level. And if anybody have any questions, they can ask me or they can message me later on the chat. And Michelle basically covered everything. I think before the whole presentation, every aspect of IoT and sustainability. And Dr. Lena basically also focused more AI green and waste energy and human perspective and the guardrails that she wants. My perspective here is just about the IoT architecture, that what we, how these things we will achieve. It's a little bit technical, but I will make it for a business perspective. I segregated this thing in the four pillars: IoT, Edge, AI, and governance. Dr. Alina also mentioned the governance and all Edge devices thing, but ultimately, these are the main thing when we talk about IoT architecture. So, why this matters? This matters. This topic matters because as we are moving toward the transformation and artificial intelligence, we have more leverage about the thing. The things maybe we have more processing power. We have more uh, virtual capabilities like cloud. We have a digital twin. Before we do have some sort of dashboard. Now we have a digital twin. Digital twin is nothing but some sort of, like Dr. Lena said, that predictive analytics that will help us. So I will not read each and every bullet here, but the main theme of this thing, why it's matter, because things are more inexpensive. Now we have more capability of edge computing. Now we have the improved artificial intelligence and machine learning analytics. Now we have more integration of technology. All those things are there. That's why we are talking about this subject. Before, or you can say existing, even the traditional model was the measure monthly basis or weekly basis and report after the fact, and the and record react late, because we are doing everything with the periodic maintenance or periodic monitoring. And based on our those Excel sheets and stuff like that, we were doing some decision. Those decisions supposed to be taken by us before anything happened, but we are doing after things are happened. So that was the traditional model. The new model that right now that we are focusing is sustainable model, in which we have the science, detect, act, and prove outcome. And why I put the prove outcome, because of these three factors, because we have the sensors, because we have the analytics, because we have the edge, like that Linda said, at the edge computing at the end of the tunnel. Sometimes we need to do from actuator meters. So those are the also depend on the thing that how edge computing is happening and how we will transform the data. So all these sustainable model factors that I'm saying, uh, we can come up with a, a measurable outcome, product or result. That's why I say the proof outcome. The core idea of about this whole IoT um, architecture is basically how we sense. What are the how we sense mean that what are the factors, what are the things that we can automate and process by deploying smart meters, pump, HVAC, water flow, pressure. Those are the sensors. Then we do have the process, then we do have the we have the act what to do, and we have then the quality. Well, what are the threshold, what are our parameters, those type of thing. Those are the core idea when we talk about IoT, infrastructure or architecture. The reference IoT architecture sustainability, basically we divided in a different manners, but in a high level thing, for a non-technical person, this is a very highly technical thing that when we talk about IoT architecture. But whether technical, very technical, but we need to have something in a very basic level, and basic level is field layer, edge layer, cloud platform, and decision layer. And each layer or each component or each silo or each work stream basically giving you a special responsibilities, function. For example, when we talk about field layer, basically what we're talking about in the field, what is happening, what are the meters giving the signal to us, what are the actuators, what things we are trying to measure, the water pressure, water leakage, mobility, whatever you can imagine. Those are the our data point or input point. The edge layer is basically how we will filter what are our anomalies, what is the detection, how we will prioritize the thing, then how we will transform the from point A to point B if we are using a cloud or platform where we can virtualize the digital twin type thing. And then we do the decision then how, what we have to do with the data that we have, what are our rule to manipulate or make it happen or do our decision based on the data that we do have. So that is a decision layer. Field layer make asset measurable. Asset is nothing but whatever the factor, what are the component, whatever the thing that we are measuring from energy perspective, water, building, agriculture, you name it, from soil moisture to water flow to smart meter, everything is whatever we want to measure. It is something that is called field layer. Edge layer basically is a further elaboration that what they segregated, how detailed we can go to the edge layer. It is the filter, the detection, the control, the log, what happened, why it has happened, how long, all those type of things is the edge layer functions. A cloud operate from the enterprise intelligence, where that all the data is coming, and how we are manipulating or massaging the data. If there is API integration, if there is any kind of modeling that we are doing for our analysis. So all those things come up with the cloud perspective. Then decision and governance layer, because without any if we have the information, if we don't do that decision based on our information, there is no point of a waste of our time. That we have the resources, we have the process, we have the models, and we have the threshold. Now we have to do the decision, and there must be a criteria, there must be risk based approach, that what to do, when to do, and all those things supposed to be done by the from a governance perspective. And also governance is basically giving you the direction that who is accountable. So we are the line of defense, that the people are using the thing, people are giving the method of procedure, the people are making the guardrails, and people are making the segregation of duties, and all those things is a part of the decision and governance layer. This is look like a very complex thing, but I try to make it in a simple form, and each box have the whole uh, function and task that we need to do. There may be a discussion, or there may be a question why we are talking about the edge versus cloud placement logic. This all depend on the scenario. Sometime we need some information at the edge, and we need to process at the edge level, and sometimes we need at the cloud, and we have the more data, that we can do the predictive analytics and can do this decision based on our whole data and samples. Why edge computing matters? Edge computing matter because of the lower latency, because when it if we move from something, the signal or actuator or sensor, this information goes to somewhere, it will take some time, and less data movement, privacy, resilience, and all those type of things. So this is a whole area that somebody can discuss. High value sustainability use cases. So there are the use cases like Dr. Lina said, the power grid, building, water system, transportation, agriculture, you name it. We can, there may be hundreds of use cases, and people in the different organization, non-profit organization, they are working along those lines, especially in Asia and in Africa. I know some people have some projects, and 2030 United Nations ESG program. They have some initiative for those use cases where they are using IoT, and some of the places it's very successful. This is another example of the edge computing. I will not, because of time, I will not do the much detail, but this is all the information that you can get, and you can do some research, and you can figure out that how the smart water network will work in a intelligence edge at the corner, at the end of the tunnel, how the things are working, what are the sensors are working, and how the audit is happening, all those type of things. Energy is a major thing, and a smart building, the energy consumption. So basically, recent development is AI plus IoT plus twin, like Dr. Lina said. All those things, basically, these are the new development, and basically, these are making us the more optimization and more efficient manner to do our day-to-day thing that can save us. Transportation and electronic vehicle charging is also another way of IoT, that these are all the use cases that we can use, and we can deploy, and we can optimize, or we can enhance our productivity and our saving. Agriculture and irrigation is also another use case where we may think it's a very high level about the soil and water sensor, that when the soil need, the sprinkle system should work, and edge integration, and how the a cloud corporation model will do the actuation of all those type of decisions that we need to make. This is another way of thinking. And this is a major slide that basically it is not for everyone, that not everyone will design the IoT architecture, but these are the basic, you can say, layout, or basic parameter that that might be, might be useful for sustainable IoT architecture. It has data monetization, cloud placement, energy efficient, privacy, and all those factor that we need to worry. And a key performance indicator is also one of the factors that we need to focus when we develop any IoT architecture. And for everything, whatever you do, it has a risk. And from the governance perspective, we need to basically mitigate those risks. And on the left hand side, you can see the risk, and on the right hand side, you can see what are the controls that we can do. For example, bad data quality, we must do some sort of validation rules, calibration, schedule, anomalies review, all those type of things. But that way we will reduce our bad data quality. So along those lines, the things are we can manipulate, or we can make it adjust. The implementation is that select a use case, define the baseline. We need to come up, because we cannot boil the whole ocean. We need to develop some baseline that what we want to do. um, Decide the case, what we want to do, the baseline, the design architecture, do the POC or the pilot project, and validate. And after that, we can do on a larger scale. Reduce ultimately
That is
the
good. Just 2 minutes, please.
yes. And ultimately the objective is just to resource reduction, response time, avoid losses, energy and carbon proxy, uptime, false alert system, audit completeness. And this is the last slide, where the main theme of this whole 22 pages or 20 pages, that don't just do the digitalized infrastructure, make it measurable, responsive and accountable. So don't think that we will deploy any IT project or IoT in implement project, but we need to see what are the measurable results. That's why I say the key performance indicator is the main thing for any successful project. Thank you very much. And once again, I thank the forum to give me a chance. Although 15 minutes very very low time for me, I can speak hours, but thank you very much.
Yeah, thank you so much, Mr. Anzak, for the enlightening presentation. And now we move to the third guest speaker, Dr. Samar Alam. And Dr. Samar, she's an assistant professor at King Salman International University in Egypt. So you have 15 minutes, please, Dr. Samar.
Hello, everyone. Good afternoon. So I'm Dr. Samar Alam, Assistant Professor at King Salman International University. I'm a former board member at ASCAD and active member for CADRIA, UN Planner for Climate Action. I'll be presenting AI UBREM data-driven model using neural networks as an AI model for energy digital twinning, demonstrating energy management systems via solar potential prediction. So I'll be presenting the problem, explaining solution, data, methodology, results, user story, website showcase, and future potentials along with conclusions. So at the beginning, we want here to address the SDGs, or the Sustainable Development Goal number 7, which is affordable and clean energy. With rapid urbanization, as by the UN stated that by 2050, 60-80% of people will be living in cities. That will be an increase in the energy demand, and accordingly, there will be a lot of consequences for climate change. Let's focus here that the AIA focused that 40% of the total energy consumption is done by the buildings. That's why we'll be focused here on buildings energy consumption. 22% is for residential and 18% is for commercial sector. That will be also the focus for the case study I'll be showing today. So our case study here for using AI in energy prediction or for energy urban modeling will be at the city of Vienna. It's one of the cities in Austria. So why city of Vienna? This is because that the data availability, and you can easily go to the websites designed by the government itself, showing all the statistics and the energy consumption mapping, and along with the renewable energy potential. So extending this research will be applying the environmental sustainable management through this model. So the model relies actually on 4 steps: the identify, assess, monitor, and maintain, that is applied in this case study and will be discussed later. So the focus of this case study is to find a solution to reduce first the energy consumption by reducing or altering the U value of the buildings, and then accordingly increase the renewable energy power. As I mentioned earlier, that the city of Vienna rely for energy districts, a percent for renewable power, focusing on the solar potential as well. So here, as we stated, that the AI UBRM will be focusing on the retrofitting of building envelope in order to reduce the energy consumption and to find a positive energy district scenario by providing a PV potential for rooftops and other building parts. So the aim here was energy efficiency along with resiliency and with focus on energy, not water, because water also is another one under study with using AI for building or urban modeling. Here, in order to retrieve the data for the U value for the city of Vienna, many other resources have been used. So what is the U value? Actually, the U value is the resistance or the thermal resistance of the building envelope to transfer heat or even cool. Accordingly, the methodology will be building data sets. We are all familiar that AI models has focus and a great concern with the data sets, as most of the AI users know that if the data set is not reliable, you can never rely on the training and you can never rely on the results accordingly. So here we are building the data set based on real data retrieved from the project and from the website provided by the Vienna government itself. It was actually divided into 2 parts: the urban building modeling or simulation done for solar radiation in order to understand or have the values for the potential renewable energy solar potential. And the other one was the energy, relying on the building topologies. I'll be explaining this later as well, for the energy consumption pattern with the focus on the U values. The second part is that training the model. For training the model, as we know, there are a lot of models for AI. We have the supervised and unsupervised neural network. So here we will focus on a supervised model with linear regression, and we will focus actually more on the reliability of neural network regression. The third part here is the model itself after training in order to test the prediction for energy and the PV potential as well. At last, we'll be applying the energy management system of the 4th parts: the identify, assess, monitor, and maintain. So here, this is like a simple flow chart for the model. The first, that the SMNX, if anyone familiar with the geodata, you need to retrieve for the buildings. And then the second part is matching this geodata with the energy data that we retrieved. The third part is the renewable energy potential, which is here very vital and new in urban building modeling. The fourth part is training the model, and at the end here is testing the model through open website. As we can see here, that our first part for building the data set relies on building simulation. Actually, we retrieved many of the buildings from the OSN open data set, and we have run the simulation using Rhino and Grasshopper in order to have the solar potential and the solar radiation for the buildings. As we can see here, that the OSMN is an open library for geodata, a geographic information system. This OSMNX library, it retrieves the longitude, the latitude, or relies on the longitude or latitude of the points we are retrieving. So how does this work? For the OSMNX library, we set a radius, and this radius retrieves all the data available and open a database for the buildings within this radius. Actually, we relied on many points, not only one point, in order to build the data set. We are all familiar, if some of you familiar with neural networks, we need to build a big data set in order to rely and train the model and have reliable results. Secondly, for the energy prediction, we mapped this energy building consumption in relation to the, or related to the U value of the buildings from the projects done by the UN, and one of these projects is called Tapula. Actually, there's another project done by the UN or funded by the UN, which is NZE. Here are a summary with the heating, cooling, and the DHW for the buildings that we used for single house base case and other actually building topologies, as we're going to show next. So retrieving this energy building consumption, we have the building topologies of residential building, detached apartment, semi-detached schools, and office building. As we can see here, this is one of the U value or the energy data provided by the government on the City of Vienna website. Here is like one of the final image of the data set built. The first one from the OSMNX library for the geodata. Secondly is the heating energy, cooling, and the cooling energy, the DHW. We have here the U value, and we have here the predicted data, which is the new U value, and the G potential, or the solar potential after that. Again, this case study focused on only 5 building topologies: the apartment, single family house, residential housing, and office with schools. Here, the second, after you build the data set, you train the model. We used here 2 models. First, we use actually 2 models, one for the solar radiation and the other one for the energy consumption. So we trained the ANN, or neural network, and linear regression. In order to understand more about how the AI algorithm is trained or is done, you have to understand now that you don't only build the data set and you use it forward on, you have to test the data set as well. So there's something called the principal component analysis, or the PCA. If someone using or familiar with the AI models, how we use the PCA, it is an algorithm, actually an AI algorithm as well, that tests the sensitivity, or the we call it the hyper parameter sensitivity of the data set you built. Secondly, you test the prediction, or the AI model for the output that you need to predict using linear regression, and another part is using the deep neural network or the artificial neural network. This is one of the iterations. Actually, it is not necessary that the architecture you used from the beginning is the one you are going to use at the end. Actually, you use the PCA, as I mentioned earlier, in order to test the data sets. I'm going to wrap up this and go through it. Actually, we do many trials or iterations. Here we have iteration 1, and here we have a second iteration, or the first iteration in the artificial neural network, iteration 2. Iteration 3, which is the last, no, this is not the last one, and here the iteration 4. So why we do all this iteration, or we always change the PCA analysis, or change even the neural network architecture as well? This is dependent on something we call the MSE, or the loss factor, or how accurate is the prediction of the model is trained upon. Here we reach the 2.5, which is, as we can see in this iteration, way better than the loss of 9.1. We have here a loss factor of 9.1, which is relatively big. So we changed the architecture and we changed the PCE in order to have a less loss factor. For the solar radiation actual prediction, this is the minimum loss factor we can ever have. So this architecture we relied on for the model, for the final model. So the second training is building another neural network or another AI model or algorithm for the energy and U value prediction. As we mentioned, we tested the data sets.
You have 3 minutes, please.
Okay. So we test with the PCA analysis. Again, we're going to repeat that for the data set, and we restructure the data set as well, as we can see here. So actually, we keep training the data and changing the architecture in order to have a minimum loss factor. At the end, we have to actually MSE loss for 3.77 with solar prediction. And for the energy prediction, we have the MSE loss function 0.00694, which means here that the data set was more successful in building than the solar prediction, and we have a better conclusion, better results. So we used the Mapbox application. It's one of the websites or an open application in order to test this model for the both productions. As we can see here, how does it work? You can easily pick on the city of Vienna as this model was being tailored, and you can here alter the U values in order to know the energy prediction and the solar potential of this. Here, the user story, as mentioned, you pick the building and you try to alter the U value in order to know the new solar potential and the new actually energy predicted as well. Here are all images from the model that we built. Some future potentials that we can extend using biomass and other renewable energy resources as well for the model. At the end, we use the EMS, the Identify, Assess, Monitor, and Maintain as energy management, environmental management system. For identifying, we used here Identify to focus only in energy consumption for building typologies that we assessed its energy consumption on the heating, cooling, and GHW. And here we monitored the existing and the new building energy use pattern, and we maintained actually the building energy performance, maintenance, improvement, and optimization with this model. I would like to thank you all for your attention. I briefly introduced this. If you want to know more about the project, it is published with the same actually title on the Springer publisher. Thank you so much for your attention.
Thank you so much, Dr. Samar, for the interesting presentation. So now we move to the first guest speaker, Mr. Jose Raudo. And Mr. Jose, he is an expert of connecting leadership, cybersecurity, and technology strategy from Chile. So the floor is yours, Mr. Jose, and you have 15 minutes, please.
Thank you very much, Dr. Wissam. Good day, everyone. First and foremost, thank you for the great opportunity to be part of such amazing initiative. I was listening the previous professionals, different approach on IoT and technology and infrastructure, and it's very insightful. Thank you, by the way, Mitchell from the Global Green Chamber of Commerce, and I'm happy to be here. So, today I want to explore a simple but really important idea. Sustainability and cybersecurity are not separate conversation anymore. In my approach and my take, cybersecurity and sustainability is the driver of cybersecurity and should be the driver for cybersecurity. As the previous speaker mentioned, as we connect more sensor devices, industrial system and infrastructure, we gain efficiency, we gain reachability, we gain connectivity, but we also create more dependencies and more potential attack paths. Let us start with a real example, just to picture the risk on real world. Back in May 2021, the Colonial Pipeline attack demonstrated how cybersecurity incidents can quickly become a physical and social problem. it was real. You can see the long line cars on fuel stations. Uh, this attack was the result of significant hacking on internal systems, affecting more than 5,000 miles of pipeline in the U.S. in the East Coast. Approximately 45% of the fuel consumed by the U.S. East Coast, and the company paid $4 million just to getting back in the business. The issue here is not the ransom itself; it is the dependency. Our modern society and the digital dependency is more present than ever. So here, cybersecurity, a cybersecurity compromise is one environment created. I hear some noise. Sorry, maybe it's me. Sorry,
Dr. Samar, can you please mute yourself? Sorry.
no worries. As I mentioned, cybersecurity compromise, in this case, in Colonial Pipeline example, is one environment created consequence across fuel availability, prices, transportation, and everyday life, right? So based on this example, this case also shows the traditional separation between IT and technology and the physical world is disappearing, and the gray line it's between two things more than ever is going to be the same. That changes the cybersecurity questions that our professional always ask. Is no longer only how do we protect our data or information. It becomes how do we maintain safe and reliable operation when our infrastructure is increasingly connected. So this brings us to the edge computing. Why do we need the edge computing? If you picture and you imagine like self-driving cars, the infrastructure is usually based on IoT devices or edge devices connected to the cloud. But what happens when we need intelligence close to the edge for processing, like navigating cities, like taking decision between navigation, how the car is going to be a place that we need to reach. So edge computing introduces an intermediate layer where data can be processed closer to the where it is generated. This provides several benefits: real-time decisions, lower latency, reduced bandwidth, and local processing and greater resilience when connectivity is lost, for instance. The edge is not just another processing layer, it becomes a new security control point and a new attack surface, and that's exactly my point here. For those who love movies like me and TV shows, here's something interesting. Leave the World Behind, a movie available on Netflix, give us another powerful lessons. Connectivity create dependency. As you can see, it's just a science fiction, but some scenes from the movie, you can see some autonomous cars just getting crazy. For instance, something like we give for normal, for common sense, like traffic lights when completely out. So that reflects how our society is more than dependent on technology. For instance, online banking. I think everyone is a user of online banking, online government, any kind of different kind, your email. So how dependent our digital society it is nowadays. So this brings us to the edge computing. The traditional model, as I mentioned, and my previous colleague speaker mentioned, is often IoT device to the cloud. That's the normal, the common before the reality. Edge computing introduced an intermediate layer where data can be processed close to where it is needed most, right? This leads to my architectural point of my presentation. Security needs to be designed into architecture, not added afterwards. There's a concept in cybersecurity community called cybersecurity by design. So my point here, we can have an IoT platform working well, uh, energy consumption under thresholds, but we need to think all IoT, edge computing, cloud computing, any kind of platform communication secure by design just to add resilience and this connect directly with sustainability. For instance, if we think about cybersecurity controls like identity, each IoT device should be identified with different and isolated identity. We should be able to allow which type of device or which device are going to connect with different systems. Segmentation limits where that connection can go. Encryption protects the information being exchanged. Less privilege limits what device can do or not do. So continuous monitoring helps us understand what's happening. Security is not one product setting at the perimeter. Security is now an architectural property of the entire system. And this is where edge computing becomes particularly interesting. The edge can do more than process data. It can authenticate devices, enforce security policies, detect anomalies. There is a trending technology in the market with different vendors. So we can add a layer of behavioral analysis to see what this IoT device is doing. For instance, a sensor can be checking different information in real time, but adding this edge layer with behavioral analysis, we can detect if this sensor is compromised, like the sensor is trying to access to a part of the network it's not allowed to, or access a public server, or it's changing information that it is not supposed to be. So my point here, based on architectural design, but secure by design, it's a great opportunity to add a security layer to enforce policies to improve security posture. So sustainability, as I mentioned, is also a cybersecurity problem. Okay. In my case, I will tweak this phrase like sustainability. It's a cybersecurity driver because picture this: compromised IoT ecosystem can cause energy waste, production shutdowns, equipment damage, resource disruption, and service interruptions. We should ask how resilient in this system when something goes wrong. A secure system is more resilient, and a resilient system is very positioned to operate efficiently and sustainably over time. So let's bring everything together. What we can learn from colonial pipeline: connectivity creates efficiency, architecture creates resilience. For cybersecurity, should protect both of them. One final thought is, if the edge controls the physical world, securing the edge is securing the world around us. Once again, thank you very much, Dr. Wessam, Mrs. Michelle. I will be more than happy to connect with all of you and all the ears to listen if any question from our audience.
Yeah, thank you so much, Mr. Jose and Mr. Anzar, Dr. Lina, and Dr. Summer, for the interesting and timely topics that being presented. And now I'm inviting Ms. Michelle and Hajra for moderating the Q&A session where there is a lot of interesting questions. So the floor is yours, Michelle.
Thank you, Dr. Wissam, and thank you to all of our speakers, and thank you again to our audience. I know that it's August and so many people are on vacation, but we still have such a great group of people, and we have a ton of questions to get to. So Hajra and I will get started with that, and I'll just ask our speakers to try to keep your answers. I know it's going to be really hard, but try to keep your answers to about 1 minute or less. And we will get started. I know Indira was the first to ask questions today, so I'll go ahead and start with her. Dr. Indira Bunik from Switzerland asks Dr. Lena, what does community data stewardship mean in practice? How do you ensure communities retain meaningful control over environmental data collected about their own infrastructure?
Yes, indeed, the insightful question from the body. Obviously, I would say that the population affect and directly impacts through the global system. For example, if I take the one rural example, there is a village and there is no any energy consumption there much, but they want to empower their electricity energy consumptions areas there. The first question goes there, that does that village have enough skilled professionals? Number one, how does it impact? Second, how can we think for more infrastructural benefits towards the more and more isolated areas? That's also again a reach. So your question is worth. And third, if I'm sure that I'm justifying your questions answers beautifully in a very short way, that not only smart solutions from the aspect of population and impactful paths to achieve, but here we need to think making a thought, a central idea whenever we invent something, that do we create that greener solution that gives us not only infrastructural benefits, plus does it impact our environmental aspects? I think this will work. Thank you so much.
Thank you so much, Dr. Lena. Always appreciate a very clear example of that and taking us on that journey. Really appreciate it. And I know I'm going to pass it over to Hajra. And I think we have a question for Mr. Ansar. If Mr. Ansar, if you're with us. Oh, we might have to jump to the next Mr.
I am here, and most of the answer I did on the LinkedIn, and Hajra might notice.
Okay, I didn't see on the responses.
Yeah.
Sorry.
We might have you do it live too.
Okay, go ahead, please. Yes, I'm happy.
This question is by Kamran Ahmed, who's joining us from Pakistan, and he's asking what key frameworks or KPIs do you recommend for auditing whether an AI model truly qualifies as green AI?
Yeah, so for framework as of right now, like August 20th, 2026, ISO 42001 and also the NIST RMF framework, and those are the framework that they give you some data point that you need to measure, and a detailed comments already provided on the LinkedIn. So if you will see he will find a detailed answer. But after this call, this is my expertise. He can talk to me and I can answer in hours and hours. Thank you.
Thank you so much. That's so helpful. I'll definitely also look back at your comments, but I'm going to pass it over to Michelle for the next question.
Thank you so much. And our next question is for Dr. Samar. And we have a question from Faisal Afridi of Pakistan. And they ask, how do we ensure that the data used to train sustainability-focused AI models is unbiased, representative, and does not perpetuate inequalities in resource allocation, that is energy, water, or food?
So again, about the data set as well, I mentioned this in the presentation. It's very essential that you rely on real data, and because some others have data from the internet or from an open database or other resources. And again, we test the data set. We just don't use it directly and train the model. we test this data set using something called the PCA analysis or the principal component analysis. It tests the sensitivity of the hyperparameters or the inputs and outputs of the data sets we are using. The second step is the AI model building or the architecture of the AI. As I mentioned, I used actually two, the neural networks, and the other one is the linear regression. Again, it relies on testing. We always test. That's why I insisted on presenting all these trials, because it's not like I use only one architecture and rely on it and this the one works. How you know that this is the best architecture, this is the best AI model? By testing. You have to test the data. You have to use the reliable algorithm for the AI. Many AI models that we have the supervised, the unsupervised, the neural network. Under the neural network, there are many types. We have the GANs as well. First, you test the data set using the principal component analysis. You take your time doing it, and then next, you test a lot of AI architectures in which you can find the MSE or the least error factor, like the one I showed in the slides. You also give it time, and once you are satisfied with the results and with the loss factor you reached, then you can rely on your trained model and the data set you used.
Thank you so much, Dr. Samar. And I know it's always wonderful to get the question and have it relate back to what was shared, because it's sometimes we just need examples of how that works. So really appreciate it. And I'm going to bring up on the screen as I pass it back over to Hajra, I wanted to share the QR code. So for those of you who are receiving each module certificate, please go ahead and scan the QR code to take the quiz. And then also hopefully you will secure at least 10 out of 12 of these certificates to receive the full fellowship. And so we'll keep this up on the screen as we continue answering questions, but I'm going to pass it to Hajra to ask the next question.
Thank you so much. This next question is for Mr. Jose, and it's by Zuhid Ibtisam, who's joining us from Morocco. And he's asking, as AI models become more autonomous, who is responsible when an AI-driven security system makes a wrong decision?
Thank you, Hara, for your question and the audience. This is pretty much an insightful question, an open line. Yeah, I think AI, it's the new normal, right? So having in mind that AI attack are going to be the streamline and the AI attack at a speed are increasingly elevating. Having AI protections in the edge will be paramount, just to be able to detect, mitigate, and react to everyday attacks, right? So my take here, just to long story short, is to incorporate in the edge layer AI-driven protection to be able to defend against AI-driven attacks.
Perfect. Thank you so much. I'm going to pass it back to Michelle for the next question.
Thank you so much. And this question is for Dr. Lena. We have a question from Dr. Gohar A. Naiku of Oman. And the doctor asks, how can green AI genuinely achieve sustainability if the growing computational demand of increasingly powerful AI models continuously outweighs improvements in energy efficiency? And so I think this is the key question here. What technological or policy measures could prevent this rebound effect?
Yeah, I can conclude in answer in one line that this thoughts-provoking question arises when we apply any AI solutions for the technical problems across the globe. Only one thing we need to keep it in mind, that whoever or whatever the company introducing and inducing the solution, one line in this answer, that is this ethical AI solution? This will lead me towards making more smarter plus greener plus actual goal of every invention to make the human life is to make the human life worthy, beautiful on this planet, rather than quarreling with finding the loopholes across the globe. You are there, you are there. No, 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 we are not doing that. So, using ethical AI, we can turn and tune such a greener AI IoT solutions based on that. And you also mentioned that how can we impact that, right? If I'm sure, Michelle, right? The
How
question
can
includes
yeah, how can we how do we balance that with, say,
yes,
policy measures to
sure.
prevent rebound
The
effect?
clear foundational answer is we can balance it through only and only green computing. And because of that, we need to grow and introduce more and more energy efficient algorithms. That requires years and years of research and developments because it's so challenging right now. So I think this is a finest answer I can give with the experience notes. Thank you.
Yeah, thank you so much, Doctor. I have to say, it's something that is just a constant question that has started from the moment that we did these programs. I know with us within the U.S. or within the Green Chamber, I know we have Mauricio Cardenas coming up talking about green AI in an upcoming model, and it's just the constant challenge that we have. And so I think Dr. Gawar for asking that question, and great answer. We just need to keep at it for sure. And I will pass it back to Hajra to ask the next question.
Thank you so much, Michelle. This one is for Mr. Ansar. This is by Mohamed Al Salhi from Canada, and they're asking, with AI governance in mind, how explainable and auditable are these given these green AI models expected to be, especially where their outputs might eventually feed into reportable emissions or energy data?
Yes, it is the same type of catch 22 question. We are not at that maturity level, but at the point in time, the best solution is that we need to keep our KPIs, or keep our threshold, and we do have predictive analytics that can help us. We cannot eliminate everything, but what we can do, some compensating control or some guardrail that can give us uh, a remedial approach before anything happen. So we are not at the maturity level. Even the cybersecurity we are doing for last 10 years, very few companies are at the maturity level. And this AI thing, uh, when there is agentic AI involved, things are very convoluted and it is very debatable. But answer in the nutshell, uh, work in progress.
Yep, I agree. It's definitely new, but it is definitely growing rapidly as well. So there's a lot of room for growth within AI. And I'm going to pass it over to Michelle for the next question.
Thank you so much. And we have a question from Dr. Tamer. This question is for Dr. Samar. And he asks, Dr. Samar, as we emphasized in Module 4, bridging the execution gap in the MENA region requires education before financing. From an academic perspective within Egypt, how can universities collaborate directly with the banking sector to design executive curriculums that teach the next generation of financial managers how to translate environmental compliance into bankable cash flow metrics? And I think this will be great for our Gain Plus
Yes.
group as well. So yeah, excited to hear your answer.
Actually, it's a very specialized question in the field of actually, has an MBA in accounting and business management. So again, could you rephrase the question in the chat or something? Because I understand that part of the question is about the execution of
I think it's about
the universities collaborate in the banking sector to design curriculums.
Yeah, how can universities collaborate directly with banking sector to design curriculums that teach the next generation of financial managers how to translate that environmental compliance into that bankable cash flow metric?
So actually, my background is in architectural engineering, but the how things goes between professional practice and academia is that while we're designing the program and the courses itself, we actually involve stakeholders that include banks in terms of business administration or management or the managerial part, and we actually. Try to show some of the students' outputs and the projects they are working on, along with the course specification and description. And they review this using a form in order to whether admit or appeal or actually reject or even suggest what are the modification or what are the marketing needs that need for the graduate or the alumni attributes as well. We call it the alumni attributes. I hope I'm answering this question, but all the universities, they have to do this for quality accreditation and the quality insurance. This is something common and accredited by all universities and all faculties, not only architecture, all the faculties are going through that. That at the end of each year, they show the project outcomes and the students' outcomes to stakeholders in order to involve them, whether these students are being attributed, are well prepared for the market or not. I hope I answered this question from Mr. Tamer Mu'min.
Yes. Thank you so much, Doctor. I really appreciate that. And I so appreciate the question because it's something that we say all the time as far as like, unfortunately, we do have to lead with financial within the business world. And if those financial managers don't know how to showcase and explain the financial benefits, it can be very challenging. So really appreciate that question. And I think that we might have time for one more from Jose. Hajra, if you'd like to ask a quick question.
Yep. This final question is by Dr. Indira Bunik from Switzerland, and she's asking, how should organizations balance the openness needed for data sharing, example, community data stewardship, against the security needed to protect critical infrastructure?
Thank you for your question, Dr. Indira, and thank you, Hashra. I think that's the everyday life, the everyday working of the cybersecurity professional, how we balance between tight controls or openness. The cybersecurity controls can be too strict just to avoid, the normal communications. My take here is to be tuning, is to be based on data, like previous speaker mentioned. Establishing baseline. I think establishing baseline just to answer the question, what is normal? So if we establish the baseline and we detect deviation, we can tune the everyday controls for organization and users and systems. So long story short, for me here it's establishing baseline and based on data to provide better controls. Thank you very much.
Amazing. Thank you so much. And that's so important to definitely have a baseline to balance both managing community stewardship and everything. I'm going to pass it over to Michelle and Dr. Wissam to close us out. Thank you.
Thank you so much, Hajra. Thank you so much to our speakers and to our audience today. I want to also give a special shout out to our collective team who's helping. We all see Hajra with us. If you're live on the chat on LinkedIn, you probably see Angelina as well collecting some of those questions. But we also have Jane and Natasha and Mila who have been helping on the back end. So I just want to give a special shout out. None of this could happen without them. And then I will pass it to Dr. Wissam, who again has brought us all together, and we're just so honored to be working with him.
Thank you so much, Michelle, Hajra, and the team, other team members. And yeah, I would like to thank all the guest speakers for these interesting presentations and the audience for their engagements, for the questions. And let me just, I think I have two comments. First, I think most of the time when we have discussion on AI and sustainability, the discussion will be centric around the negative impacts of AI on sustainability, on the environment. Less people talking about scenarios, success stories, which is the deployment of AI in serving sustainability, whether it is about the energy management, and not only the direct impact, sometimes it's indirect impact, like when you utilize like the IoT in the smart building or smart cities, of improving the quality of the environment, indoor environment, whether it's on the building or sometimes in the factories, or the deployment of those systems in managing the resources, in controlling some systems. So the indirect, whether it's cut off the energy demand or enhancing the environment, which have a lot of health implications, that will also, it will have some positive environmental impacts, health impacts, which reflect again, might be indirectly on productivity, and that all can be measured as monetary values. And I think the uniqueness of this webinar, of this module, which shows a lot of those success stories, and I think we need more of that in the future, so that we can prove to people that this discussion is not only about the consumption of energy and the consumption of water, the data center, and all these types of discussion. And the second element, which is linked to Dr. Tamer question as well, I think the collaboration between the academia and the industry, and as we discussed in our panel last 2 days, also engaging the non-profit organizations, it shapes all these programs to be up to the expectation and demand of the industry and the needs of the market, which again will produce graduates, will produce programs which is in line with the current demands in the market, rather than we just complain. I mean, from many of the industry players, that these programs are outdated. Those graduates are not incapable of doing what is the needs of the market. So that harmony, that integration, need to be done. And unfortunately, from the academic perspective, in many faculties programs, they have some advisory boards, they have some discussion, but it does not really come to a full harmonization and utilization of those members in integrating those expertise in the curriculum or in the assignments, the projects. Some of those universities are doing that, but in many cases, it's on the theoretical part. It's more on kind of prestigious advisory boards, which is not really integrated in the program. And I have one comment, one thought. I'm always thinking about it. Now I see, and this is I'm sorry, I'm going beyond time because this is something interesting. I've been thinking about it. I see in many universities, like now, they are announcing new programs like AI engineering. So I'm thinking, if a student starts an engineering program now, right? So he or she will graduate in 4 or 5 years. You just imagine now, from 1 week or from one month to another, we have a new application, new mechanism, new approach, new algorithm. So just imagine about the design of the curriculum right now. So what the contribution of those graduates in 5 years? We might have, I'm not sure what we will have in terms of the smart systems and AI technologies. So I think this is a deep discussion that we might need a special webinar. And because I'm really wondered, and many people ask me like whether their kids is it good to join these kind of programs. I'm still I can't like give a full answer because I have a lot of thoughts on those programs, which is again to somehow or other it's linked to education, it's linked to sustainability, and it's linked to AI. So again, thank you so much for your time, for your contribution. I think this is one of the best modules that we ever have because this is it's a timely topic to be discussed with a lot of contribution. I think I'm not an expert in AI. I try to learn. I try still learning a lot of things, but I think we are living in a different era. I mean, which is again from our interest and from again from your interest as well. When we are talking about sustainability, there is a lot of things which is need to be investigated, and there's a lot of contribution that we can do to harmonize both fields, which again to be served. I think Dr. Lina mentioned about the ethical AI, and there is a lot of topics. I don't want to discuss sensitive issues in that domain, but I think we understand all these issues. So I think we need more discussion on this. So thank you so much, and I'm sorry that I've gone 5 minutes beyond the time, but it was really interesting. And I really appreciate your expertise and also the contribution from the audience. So thank you so much. We'll see you next week and have a good time, everyone. Thank you. Bye bye.
Bye, everyone.
Thank
Thank
you.
you.
Bye.
Thank you.